Hello, everyone. Hello, Samuel.
Hello.
So you're going to teach us what is JSON-LD.
I'll try.
OK, please teach us.
Thank you. Good afternoon, everybody. I know it's pretty late in the afternoon and you're trying to fight to keep energy. I'll try to keep you awake as long as I can. Welcome to this JSON-LD talk. Why do we care about that, and what is it? That's the idea. I'm really super happy to just first of all be on the stage and see people, and it's the first API platform conference. Honestly, it's just unbelievable to see how it's grown. So thank you so much for just being there. That's really amazing. I'm Samuel Rozé, so I'm officially core team member of API Platform and Symfony. Even though very recently I didn't put too much code into that. And I'll talk about JSON-LD because it's a topic that really interests me, but also something that I'm experiencing at the moment with my current company. We work in healthcare, trying to help elderlies to stay in their own homes instead of going to care homes. And part of doing that is to be able to structure information and to be able to share health information with others. And that's kind of where and how I got into being interested in this topic. The rough agenda, we'll talk about JSON-LD, very high level. We'll just briefly touch around why do we even care about that. We'll then discuss RDF, which is the foundation for JSON-LD. We'll go into more details and how JSON-LD and API platform sort of work together. Just for you, API platform users, it's probably something you're all kind of aware of. It's just you're already using JSON-LD. It's these kind of add something in the API responses that actually make that all part of the JSON-LD flavor of your JSON API. And hopefully by the end of this talk, you'll know exactly what this thing means and why they're there. So JSON-LD, it's part of the Semantic Web. I've put a few snippets from Wikipedia, or source of all. JSON-LD is a method of encoding linked data using JSON. The idea is that as engineers, we are pretty familiar with JSON, and that's our kind of main preferred way of serializing data. Some people have sort of created JSON-LD so that we can add a bunch of stuff to the existing JSON documents that we have to create more meaning from this data and to transform it into a quote-unquote linked data. Linked data is a way to structure data so that interlinked data sets together create much more value. It's quite abstract, it's quite generic. The ultimate idea is that we move from a web of, or an internet of web pages, which is for humans to kind of read and consume text, to a sort of a global distributed database that we can infer more meaning from the various different data sets that we all create. That's the rough idea. Now, one of these, and it's built upon existing standards that you all know about, HTTP, URIs, and RDF. RDF is, at least to me, the standard I knew the least, and is kind of the underlying foundation for linked data. And RDF, it's a resource description framework. The main concept is that it is a set of tools for us to model the data that we are dealing with. It's quite abstract. We'll see exactly in detail how it works. To quote Tim Berners-Lee, which is the father of the internet as we know it today, web pages are designed for people. For the semantic web, we actually need to look at existing databases as a source of inspiration so that we can replace them and create this web of data rather than just web of pages. That's the ultimate idea. All these things I'm going to talk about, JSON-LD and RDF and stuff like that, have been created by this group of people, or the World Wide Web Consortium, which is also known as the W3C. It's been created, I think, 25 or so years ago by this guy, Tim Berners-Lee. And I'm pretty confident that you know them, mostly for their quote-unquote presentation layer formats. So that's all of the HTML, the CSS, SVG, even like SOAP for the old ones. All of these specifications or standards have been created by them. There's another kind of like spectrum of specification that they've created, which is more on the data layer side, which we are usually less familiar with. That is usually, or like this set of standards are usually referred as the Semantic Web stack. So that is RDF, which we will dig into, SparkQL, which is a query language for linked data in a way, Shackle, which is a validation engine for RDF data, Howl, which is a ontology language. We'll briefly touch upon that, but it's a way to describe the data that we are exposing or giving to our customers, JSON-LD, and a bunch of others. There's an entire punt, or like an entire part of the W3C, which is really focused on that, making more interoperable data standards so that we can go in this direction. Now, why do we care? So there are two kind of main goals for the semantic web as a whole. It's create just like data, create more meaning from the data that we have, so that automated systems, might be search engines, might be whatever things you will create, can actually understand the data that they read from various different sources in a better way. And ultimately, it's in order to enable interoperable systems. So it's a simple way to say that if we kind of like all go towards the same way of modeling the data that we hold in our various different applications, we create more interoperable systems, which means that for us as users or customers, we are way more like enabled to change providers and to keep our data and to move it somewhere else. Using these kind of technologies, I've clearly two main business benefits. I guess the first one is around the availability of this data to the people, namely search engines. It gives more visibility to your own data. Clearly, especially for e-commerce, it just means likely more traffic, and it likely just means more revenue. So that there is a direct incentive for businesses to kind of like explore these data standards. There's another one, which is that if we actually from the ground up build something that is interoperable, later down the line, merging systems together or integrating with other systems is supposed to actually be way better. I'll show you an example of that. But that is a sort of like short-term decision that leads to really like long-term benefits, so that maybe in a year or in 2 years you won't spend many months on integrating with something else, but only a few days because you've kind of like invested in these standards from the beginning. And there's also a sort of like an ethical consideration I'd love to touch on, which is we live in this world at the moment, which is quote unquote the data economy, in which data is quote unquote the new gold, creates value, create more and more value. The more data you have, the more value you kind of like you can touch and create. And at the moment, this data economy is really siloed. So you've got the Googles and the Facebooks of this world that kind of like have most of the data. What it means is that it's quite hard to get that data back and to really get the benefit of all of the data that all of us collectively create. Working on these kind of standards or like tools that make things more interoperable is very likely to contribute to enabling more innovation and very likely reduce the inequalities. And it's mostly inequalities of opportunity to start a business or to actually try something new, rather than just being sort of like only accessible to the large corporations of this world. So I think that's one of the reasons we should care about that. I will share the slides later. There is one link with many of the whys and the benefits from an ethical and a technical standpoint. Just to illustrate my point, it's just 2 articles. Again, there are the links, there will be the links in the slides, but it is more and more apparent that we need to do something about this concentration of data and therefore opportunity that we There is no way that we are going to sustain as a group of people if we just let that continue this way. So we need to find ways, maybe in our small in small ways, we can actually make it better. So from technical standpoint, so JSON-LD is actually one of the serialization formats of RDF. So JSON-LD is one way to serialize RDF data. And JSON-LD just provides context to your data so that it becomes much more useful when interlinked with other data sets. Again, same idea, just rephrased, really. So RDF, this is the abstract from the RDF specification. It's quite a hard piece to read. I'll just highlight two things, or three things. The first thing is that RDF is an abstract syntax, or it's really more of a data model for how we structured our data. It is built around graphs. So all of the data is represented as graphs. And we create graphs by creating triples. So subject, predicate, object. And these triples are just parts of the graph. And this kind of like last point is that within RDF, every single identifier is an array. It's something that's globally unique in your application, but in all of the applications out there. This is the main principle. So we can actually boil down the abstract to 2 points. RDF represents data as graphs, using triples. And everything is a array, unless it's a literal. And the literal is just an actual value. Make sense so far? Yes. So RDF represents data as graphs. So for example, we've got Barack Obama and United States. What do we have in common? He was the president. RDF represents data as a graph, so a relationship between two things. You can see in blue, these are arrays, so every single thing is just a full array, and that's its own kind of like unique identifier. Now, so we say that Barack Obama was president of the United States. We can also say that Barack Obama's first name, or just name, is Barack Obama. You know, that kind of like thing uniquely identified as Barack Obama as the Wikipedia link, as a property represented as a edge on the graph, which is his name. Also as a birth date, also as a spouse, which is Michelle Obama, which actually his name is really Michelle Robinson. And then Joe Biden also is president of the United States, etc., etc., etc. You understand the idea? Every single piece of data is represented this way, as a graph in RDF. So there was this kind of like idea of triples. This same data represented as triples is really the same thing. So triple, again, it's a subject, predicate, and object. Subject is the resource we're talking about. Predicate is what we want to say about this subject. And then the object is quote-unquote a value, what we want to actually refer to during our kind of like fact statement. So typically, Barack Obama, president of the United States. Subject, predicate, object. Same thing with literals on the right in green, where Barack Obama's name is this one, Barack Obama's birth date is this one, etc., etc. Every single one of these lines is a triple. Just that principle make it extremely simple to just represent anything we want as a set of triples. And that is the underlying foundation of the rest of the RDF model, basically. It's just to agree on these things, we structure data as triples. Now the second rule, or principle, is everything is a array. So there's two things. So there's arrays for the subjects. So typically Barack Obama. The idea is that you must be able to uniquely identify a thing across multiple data sets. For Barack Obama will be the same thing whether it's from company A or company B's database. And the idea is that using these arrays, there is no kind of like wondering of you've got this ID 2 on one side and then this ID 2 on the other side. Is it the same thing? You don't have to kind of check another field, which is the type or whatever. You are able to then merge these things together because they have this globally unique identifier. And there's the other aspect of iRise, which is iRise for predicates. For example, president. You probably have seen that we were using an iRise for that as well. The main idea is trying to uniquely identify the fact that we're saying. Typically, there will be confusion. In some data set, parent might be the relationship parent-child. In some others, it might just be parent as the kind of hierarchical organization of categories and stuff like that. When you get this data set, you want to understand what is the meaning of parent. And having a full IRI means that parent will be actually a different parent regardless of these two use cases. So then we can have much more context around what this data set means. On top of that, what it means is that we can also attach metadata, we can attach things directly to this predicate. So for example, we can also describe within the graph, we can kind of like create a piece of graph from the predicate itself, so the thing that is in between two IRIs in my previous examples. And we can then say, actually, spouse, well, the inverse of that is husband. And actually, spouse, we can have various different descriptions and stuff like that. And we can create more metadata and documentation on our data sets and the kind of relationship between things this way. That is usually called an ontology. And it's something that kind of like, it's a documentation of the data model in a way that you're using in your data model. Yeah. Quick note on ontologies. So it's just a dictionary of terms and documentation of the relationship or the terms that you're using, why you're using them, and potentially added value, like inverses and stuff like that. That's where this thing, which is called OWL, so the web, the ontology web language. Actually, you need to sweep these two. Is a sort of like something on top of RDF that enables you to describe this thing. Think about it as the OpenAPI spec for your RDF dataset. That's really similar. So far in all my example, and I think even after, I'm using the full name, the full IRI for every single thing. It's just a bit painful for us as engineers, so just so you know, usually we prefix all of these things with prefixes. So we will just say actually, instead of saying schema.org/birth date, we will just say S column birth date. A few ontologies that are worth knowing. RDF and RDF schemas come with a bunch of things. Typically, the fact that something can have a type, with names or labels and descriptions and things like that. Kind of a common vocabulary for most of the very, very basic things. HAL also comes with some terms that you can reuse, some predicates that you may reuse for example, the same as, just to describe that two things are the same. There are things, the friend of a friend is one that enables you to describe relationship and kind of like network related data sets. And then you've got sort of like higher level ones, like schema.org that you might be familiar with, that describes what an event is, what a place is, what a car is, and things like that, and the various different properties associated to them. So you can go on schema.org and kind of find many existing concepts that have been described that you can actually reuse the same predicates, so that then you can share this data with other systems and they will understand it. DBpedia is another example where it's the structured data version of Wikipedia that contains so many things. So it will actually describe what a president is, what a food is, what a pizza is. They will actually describe as RDF, as graphs, so much of this existing data in Wikipedia in a structured manner. There's plenty of other ones. FIRE is the last one here. I'm working in healthcare. That's one specific to healthcare, and it's really good at trying to understand how you structure an observation, a procedure, and medication request, and etc. There are plenty. There are honestly like a lot of these ontologies that you can reuse. One of the great things on reusing one is that you will spare so much time of thinking what is the right property name, etc. Just better use something that people already invested some time in designing, so that you don't have to do that. And you can share that with others. So that's kind of like one of the main points of interoperability, is to be able to reuse similar ontologies. Now, just a quick example on why, from an interoperability standpoint, merging data sets is way, way simpler if you actually go full-blown the path of using identifiers that already exist and represent your data this way as a graph in a way. So in this example, I have two shops on the left, the Phrygians and the Aspendos. You can see that the Phrygians, through its relationship, so through its predicate city, is actually in the city of Londres, that Aspendos is in the city of Lille, and that there are like potential actions. Not too sure is the right predicate to represent that, but you can actually get some kebab and carmelites at the Aspendos. Really recommend it for whoever is in Lille. You can actually get some beer and some pizza from the Phrygians. And that is pretty much your data kind of like structure that you have in your application at the moment. What if, hypothetical use case, you now need to actually display the name of the president that is, or the president of the country in which the shop is in, as well as whether they serve food or not. If you were kind of having your own data set, your normal, hey, this is the city name, hey, this is what they serve from your drop-down of things, you would have to then create your own sort of, your own mapping that says this city is in this country, and this country's president is this guy, and you need to, or this person, and you need to kind of maintain it. Same thing for all of the potential actions, like all of the things you can get from this shop, you would have to maintain whether this is food related, this is not. Actually, what you could do, if your data is reusing these lovely identifiers from Wikipedia, for example, well, you can get a data set from DBpedia, download it, you put it in your application, and then you can directly link the fact that, or you can directly query the fact that pizza is actually of type bread and it's therefore of type food. Same thing for actually the president. So city, Londres, it's actually the same as London, great. And then London's country is United Kingdom, and United Kingdom's president-ish is Boris Johnson. The point here is that you don't have to do any data transformation because you have the same identifiers. You can just follow the path and you have a good understanding of what is what. Which is honestly great, and there's so much pain if you don't have things like that. Short version here, use as much as possible existing identifiers or existing data sets, just don't reinvent yours, ideally. Now, in kind of like more concrete things, RDF has many serialization formats. JSON-LD is one of them. There's many others, Turtle, which is your triple text file, more or less, and free. You've got XML version if you really, really want it. If you want some pain, you can go there. RDF-A, which is RDF as HTML attributes. There's plenty of things. The real point of serialization format is that how do you move from this hypothetical model that is really powerful to an actual thing we can use? Just a quick one on Google's rich snippet. I'm pretty sure all of you have used Google in the past. And I've seen these wonderful snippets of the product ratings and stuff like that. It turns out that Google, in order to do that, needs to access all of your information. And it needs to actually have a good understanding of what is it that you want to index. Oh, that's a product, that's great, there's this rating, that's great. The way they're pushing it is that you need to just give the RDF data to Google so that they actually understand what your product is about. And the way they do that is that they force you to use the schema.org ontology so that you talk the same language that they do so they can get this information. The way that they read the RDF data is a bit of a technical detail. Now they do recommend just a JSON-LD blob on your website. In the past, there was another serialization format. I think that was the preferred manner, which was RDF-A, as in like you put everything in the HTML attributes. The point being, this is all about RDF and not necessarily just details about JSON-LD. Cool, JSON-LD itself. So it's actually JSON linked data, if I didn't mention it yet. There are a few fancy things. So this is the output of the /books. I mean, you can see the URL at the top. It's the API platform demo. This is just a list of books. What you can see is that you've got @IDs in there. Every single object, one might call it a resource, has a unique identifier as an IRI that is globally unique and identifiable. We don't need the actual prefix because we can guess the current domain name, but that is a full URL, URI. On top of this ID, there's this like mysterious @context, which was really mysterious for me for quite a while. And the point of this @context is just simply to actually be able to, as a reader of this API, to try to understand what is the IRI of all of these properties that I'm talking about that are in this document. That's pretty much it. So if we actually follow the path, the /context books, we actually have here a context file on the other side there. Whether that context file actually could be directly embedded in the first one is just a detail that is in another file, let's say. What this thing does is multiple things. First of all, it defines this at vocab at the top. It just says that basically the default prefix for everything will be this one. So default prefix to put to the existing fields like title, description, etc., to get the full IRI is this vocab. Now it also defines few things. Typically, we'll say, well, actually, you see description and title. Actually, there would be the IRI of title and JSON in the JSON document in there is actually schema.org/name, which means when you read that thing as a computer, I assume you're a computer, you read this thing, you can understand that this is about the title is actually the name. Because that's the thing you're looking at. That's the ontology you want to get, is the schema.org ontology, in the Google example, for instance. And lastly, it also describes prefixes. So you can see this Hydra column number. It actually maps to Hydra as well, and is, again, same thing, it's just a prefix. So ultimately, what we have from that is that we have the ability to have an identifier of things and all of the IRIs for all of the properties. That is it. And you can already see that at the end, we actually have an RDF data model by just doing that. JSON-LD actually has multiple forms. The forms that we mostly see is called the compacted one. It's this kind of document, the one I've showed you before. It looks like a normal JSON document, not too dramatic to read, no graph-related things. There's also another form, which is called the flattened form, which is more graph. It describes graphs. So here, actually, all of the all of the kind of like statements are grouped per subject. Subject is the @ID, and each of the property is a predicate, and each of the value is an object. So now you can actually see how it maps into triples. I hope so. Tommy, works? Yeah, maybe. You can easily move from the compacted version to the flattened version. It's a process that can be completely automated. The other way around is a bit trickier. So there's this thing that you might need to know, which is called JSON-LD framing. Somewhat working well. Sometimes it's a bit fiddly to work with. But the idea is that you take both a graph, so all of the graph, so on the left, top left, you've got the graph kind of like representation of some data in JSON. You merge it with a frame, and at the end you've got sort of your structured, kind of like easy to use JSON file that you can give to a front end. So this is a very important tool if you actually import data from other RDF sources. Maybe you have a big turtle export from, let's say, Google Knowledge Graph. They actually do exports of, or they did export, they did stop doing new ones, but they do exports of the entire Google Knowledge Graph you can download as a file. You can actually, that's a turtle file. You can then ingest it as a JSON-LD kind of like graph structure, and then you can reframe the documents in the format that you want. You've got access to so much context and data that you didn't have before. Now, cool. I have a JSON-LD API, now what? Well, first of all, just you can use it as a normal API. There is no need to do anything else, which is convenient. But then I just want to touch upon one thing, which is how do we query RDF data usually, and where is the power of this data structure? There is one thing which is called SparkQL, which again is another W3C standard that I've mentioned in the past. It actually means SparkQL, Protocol and RDF Query Language. It's like PHP maybe. So think of it as the SQL for graph. You can do joins, wheres, aggregations, filters, whatever. And it enables you to query RDF data structures, whether they come from JSON-LD, whether they come from like Turtle or RDFA, it doesn't matter. It enables you to query these things and to follow graph relationships. Typically, in the example that we had before with the shops and the president and whether they serve food or not, a SparkQL query will look like that. It enables us to actually query this graph data and follow the relationship in a really simple way. First time, it's maybe a bit hard to grasp, but it's really simple. If you start at the beginning, you kind of like find all of the things that you put in the variable shop that have a type shop, that have this triple, something, that is a type of a shop. And then you get this shop and you kind of like follow the country president relationship and you get a president as a variable. And you set the top, you select it. Optionally, you do the exact same thing with the food activities. Really funky things in there where you can do like property paths following. So actually it follows all of you remember the pizza, bread, food, whatever. That is a way, so you can just continue trying to understand through how long the path might be, whether something is of type food or not, typically. You can do crazy complicated data model or have crazy complicated data models and relationship between things and have really, really simple queries to get your answer. It's really interesting. And the even cooler stuff in there is what is called federated SparkQL queries. In the example I had before, you kind of still need to put all of your triples somewhere in a triple store. There's plenty of open source ones. You can just have them in a normal JSON file, and then you run something on top of the JSON file to run the query. It's not super convenient because you kind of like need to have the data to download it first. Maybe very convenient with ASI, because it's already downloaded. But there's this thing of federated SparkQL query where you can actually distribute querying this RDF data over so many services, as long as they do expose a SparkQL endpoint. The SparkQL engine would just do HTTP equals to whoever it might be. Typically, slightly change SparkQL query from before is this one, where you actually instead to try to understand whether something is a food or not, instead of having this data set that you've downloaded from DBpedia somewhere, just don't bother. Just don't bother. And you can actually ask directly the query or parts of the query to the service that owns the data. In this example, DBpedia. By doing that, you don't need to store anything but food whatsoever. However, you have your answer to your question. And that enables you to actually distribute querying across so many different data sets, so you don't reinvent the wheel. And you can even use that across multiple services within your own organizations. There's many interesting things we can do from that aspect. And the hood is just HTTP request, fantastically cacheable, no funky GraphQL things and others. Now, with API platform, honestly, it just cannot be simpler. In order for you to make them JSON-LD, you just need to have add this IRI. It's going to change if you saw Antoine's talk. But you just need to actually set this IRI. This is the full IRI, and API platform will generate everything. We generate the context, the kind of like type, IDs, etc. You don't have to do anything. Now, there's one cool stuff, which is the schema generator. What you can do, you can start with schema.org, go into all of the existing concepts that they have, car, events, place, whatever. And then you can actually pick the times that you care about, the properties you care about, put them into a YAML file, run this command at the bottom, and bam, you've got all your entities with the right IRIs, with the right annotations, and you can get going, you already have your API. Super easy to have something that then will be understandable by other machines than just your system. Now, in short, because we need to wrap up, I've been told that we cannot go on and go on. So JSON-LD is one of many RDF serialization formats. RDF represents data as graphs, and it uses triples to do that. In RDF, every single identifier is a URI, or everything is actually an IRI, except literals, so actual values. There are many ontologies. These are the real things that help us to build interoperability. You can use SparkQL to kind of query your RDF data. You can use federated GraphQL to just even more like unlock the ability to just not even move data from where it belongs. And it is extremely relevant to you because even if you don't have them yet, you will definitely have integration challenges, like the one I've mentioned with the food and president or others. Thinking from the get-go of your strategy so that you can have globally unique identifiers is going to pay off massively in 6 months, a year, 2 years. There are business benefits as well, as we've mentioned with the Google kind of like ranking example. And lastly, we are all engineers, and we have such a massive privilege, which is that we can make very small technical decisions like that using JSON-LD, very little complexity, that can, bit by bit, kind of like really have really substantial impact on also the way that our half-working data economy seems to be working. By actually just pushing it one by one, just a bit more interoperability, a bit more standards, we are actually making it way more possible for somebody else to create a company from the existing data sets and create value, and not having this value being captured by a necessarily large corporation that don't need more money. That's it. I just wanted to let you on that idea, and thank you very much for listening to this talk.
Thank you very much, Sam. Are there any questions? Yes, we have one question over there. Please, mics, guys.
I can go as well.
No, don't drop the mic, please.
We need to keep him.
Okay, but we are short in time, so it will be the only question.
Thank you. Sorry for making you hard. Thanks for the talk. It was a question. I think I understand how, with your talk, how we can map the data with Schema.org, for example.
You can do it in French if you want, I can translate.
OK. Je crois que je vois comment on peut mapper des données avec Schema.org. Je pense que je vois l'intérêt d'utiliser un endpoint comme SparkQL. Par contre, j'arrive pas. Enfin, là où je serais preneur, c'est comment on peut mapper une API, l'output d'une API comme une API qu'on générait avec API Platform avec un endpoint SparkQL.
So the question was, how do we kind of like bridge or create a bridge between your API platform API and being able to query it with SparkQL, basically? And the short answer is it's a tricky one. So really, what currently the kind of like best way to do that is by kind of crawling your API platform, the list of collections. You get a collection with all of your entities, and you can potentially get all of the entities one by one. You export that, these JSON-LD files. You put them on the disk. You kind of merge them together very easily as the flattened version, and then you've got a SparkQL engine that can use the file as your database in a way. You can also run the SparkQL engine directly on one HTTP endpoint. But the problem is that it might not need, or it might not have all of the data that it needs to kind of like run that query. So that's where there is this kind of like gray zone where there might be sometimes there is a need for a kind of like pre-aggregations of the API platform endpoints. But actually, I should have started there. You can already run SparkQL on the file that is outputted by your API platform endpoint. It's a compatible RDF thing. And then you have other kind of like tools or things that are sort of like reverse proxies that exposes SparkQL endpoints, so that you have a better understanding of like how to browse and how to discover your internal data sets. So there are some things typically if you want to do a query that is based on many different resources that are not necessarily linked to each other. You cannot have just one starting point, so you would have some reverse proxies that do that.
Okay, thank you.
Thank you.
Apparently, we have one interesting question online. Could you answer it quickly?
I'll try.
Question, please.
Okay, the question is, how can we benefit from Google Rich Snippet when making a PWA? Will the Google bot automatically fetch endpoints by running JavaScript part of our pages, or should we embed JSON-LD blob manually somewhere?
I'm actually not too sure, so you need to actually validate what I'm going to say. But last time I did that, basically you actually needed to embed the JSON-LD document within the content of your page. And whether it's just generated by JavaScript or it's server-side generated, that was the main way of doing it. As far as I know, you can actually now, using the link headers, you can actually point to a JSON-LD file so that Google will crawl it. That's the latest I know. Honestly, it's not my main area of expertise. So. It's done by default for API platform Next.js client generator. Well, we didn't say how, so please go and talk to him.
Okay. Cool. Thank you very much, Sam.